Hello again, welcome to another lesson in Algebra 1. Today we are covering Chapter 1, Section 6, Basic Constructions. All right, so first we have a warm-up here, and as always, doing the warm-up yourself will really help you and then learn the material better, and then you come back and check it over. So if you have not done the warm-up, you're only hurting yourself by not pausing the video and doing it first. All right, number 1. Draw an accurate and labeled picture of each. So vertical angles ABC and DBE. So remember, vertical angles are formed by opposite rays attached to each other. So let's go ahead and pull out our ruler, straight edge, and we'll draw two rays. Okay, so here's one. These are two sets of opposite rays. So these opposite rays. And then we need one more set. So move the ruler down a little and draw the other set of opposite rays going through the same point. And then we have vertical angles, so let's draw an angle ABC. So B has to be at the vertex. So there's ABC. And AB is supposed to be opposite of somebody over here. So let's see, so we'll put D on this one and E on that one. So AB and BD are opposite rays, and BE and BC are opposite rays. So we get this guy in here, and we have vertical angles. And to show that they're vertical angles, we can also do this, because all vertical angles will be the same. Okay, and we'll learn about that later. All right, supplementary angles C and D with the measure of angle D equal to 40. So supplementary angles. So it doesn't say they have to be adjacent, so they don't have to form a linear pair. But I'm going to go ahead and, well, I can't draw them as a linear pair because C and D, those are the vertexes, and C and D have to be at different spots. So I'm going to draw one angle over here, and we'll draw the other angle over here somewhere. And make these accurate, because one of them has to be 40 degrees, we need to pull down the protractor and measure out a 40-degree angle and a 140-degree angle. So we'll do the 40-degree angle over here first. That's going to be right there. And then we'll come over here and do a 140-degree angle. So that would be right there. All right, so we'll create our ruler and draw a nice straight edge. Hook them up. So here's our first one. That's going to be the 140 because the two angles need to add up to 180 because it's supplementary. And then this one, hopefully I shouldn't have to move my ruler again, will be my 40. All right, so we're only supposed to name these angles by their vertex. So this could be angle C, and this guy is angle D. And we know this is 40, and to prove that they're supplementary, I'm going to have to put a measure on this one. So this one's 140. Now, once again, we cannot draw them as a linear pair because they have different vertex points. So one is C and one is D. All right, our last, number 3 here, acute angle MIN with the angle bisector IE. All right, so I'm going to go ahead and use my protractor to mark all the points here. So I'll put a vertex. I'll drop my protractor on the vertex. And let's see, we need an acute angle MIN, so we'll make it be 60 degrees. And then we have the bisector, so the bisector is going to have to be at 30 degrees. And then we'll mark our spot here also. All right, get this out of the way. We'll draw in all of our rays for our angles, all of the sides of the angle. So there's our first one. And here's our second one. And here's our third one. All right. So we still have to label this one. Acute angle MIN. So we'll put M, I, and N. And it has an angle bisector IE. And how do we show it's an angle bisector? Well, we're going to do this. Okay, and we can see it's acute because it is definitely less than 90 with the straight corner of the paper test. Okay, all right, our last question here. RA and RE form straight angle ARE. Okay, well, this one's not bad to draw. We'll get that out of the way. So here's our straight line, because that's a straight angle when we're done. and here's RA, and here's RE. And they do form angle ARE, which is a straight angle, so we'll put 180 degrees to show that. All right, that concludes our warm-up. Let's flip it over and look at some of the basic constructions. You will be required to do constructions in class, so make sure you watch this and follow the steps. We'll practice it some more, but then on the quizzes and tests, you'll have to be able to produce these basic constructions. All right, on our second page, you can use special geometric tools to make figures that is congruent to the original figure without measuring. So remember, congruent here means it's the exact same. So same size, if we picked them up, we can lay them right on top of each other. This method is more accurate than sketching and drawing, so we're not going to use rulers where we count how far it is or use protractors where we try to measure. Instead, we're going to use two other tools. Okay? Our first tool is just a straight edge, so in other words, a ruler with no markings on it. So I'm going to use one with markings because it's what I have for my straight edge, but you could use just a side of a paper or something. Okay? Our second tool is a compass. It's a geometric tool used to draw circles and parts of circles called arcs. Okay, they look different. You can buy compasses that look like the one down here in the store, or there's safety compasses if you're using one that I provided you in class. Okay, it looks a little bit different. All right, so constructions are geometric figures drawn using the straight edge and a compass. And they've been done for thousands of years, all the way back into the times of Greeks when Euclid invented what we call modern geometry. Okay, all right, so draw each basic construction. Constructing congruent segments. So this is a very basic construction that you'll need to know the directions for. There are 3 steps to it, and it's pretty straightforward. So given some segment AB, that's over here, we want to construct a new segment CD so that they are exactly congruent. So in other words, if I pick them up, cut them out, lay them right on top of each other, they would fit perfectly. Our step 1, draw a ray with endpoint C. So we'll draw it down here. Okay, here's a ray. There's endpoint C, so that's one side of it, and that make it a ray. And now our second step is to open the compass to the length AB. All right, so I already had my compass sitting and ready. So if we sit it here, you can see what they mean by that. I have to scroll up a little bit. So I put one point on A, where the pointy part of the compass is, and I put the pencil part on B. Okay, so I opened up my compass till it fit exactly on AB. And then it says, well, then we'll show that this fit perfectly. We'll draw a little arc here. All right. And you can see that that fits perfectly. Okay. So then it says with the same compass setting, so don't move your compass setting. We're going to pick up our compass, and we're going to move the pointy part to C, and then we're going to draw a new arc. Okay, and that will mark it so that I know that these two are the same length because it measured here and it measured here. And where it crossed the arc and the ray, we're going to put point D. And now I've constructed line segment CD. CD starts at C and ends at D. That is exactly the same size as AB, so it's congruent to AB. No ruler needed, didn't measure and try to remeasure down there. Okay. All right, so this second one, number 2, use a straight edge to draw XY so that XY is equal to 2 times the length of AB. So the value of XY, if I did measure it, is equal to 2 of the values of AB. All right, so this is very similar to construction number 1. So what I'd like for you to do is pause the video and think if you could think of a way to do this. When you're done, come back and check it and see if you got the same thing. Welcome back. So first thing we're going to do is, just like in step 1 up above, we're going to make a ray. We're going to make it really long because it needs to be twice as long as AB, so we got to make it longer than that. And we'll put X on the end point here. Okay. Now I still have my protractor measured out for the length of AB. So all I need to do is bring my protractor down. And if I mark this in, there's one AB's length. And then I can pick up my protractor, move the pointy part to where the arc and the ray intersected, and draw the other length AB. And now when I'm done, I know that XY, put Y where the intersection of the arc and the ray meet, is the same length as two ABs. I don't know how long two AB is at all, but I know that XY is twice as long as it was. All right, let's flip it over and take a look at the next page. On the next page, we are constructing congruent angles. Okay, so given angle A, we want to construct angle S so that A and S are congruent. All right, so this one's a bit trickier. There are 5 steps to this one, so you may need to watch it twice to make sure you know what you're doing, but let's go through the 5 steps. Okay, our first step, draw a ray with endpoint S. So we'll go down here, and we'll draw a ray with endpoint at S. Okay, so I'm going to go ahead and put my straight edge down here, hopefully, and draw a ray. Doesn't matter how long you make this ray. The longer it is, usually the easier it is to work with. So here's endpoint S. That's going to be the vertex of my angle. All right, step 2, with your compass point on vertex A, draw an arc that intersects the sides of A. So here we go. Oops. Set our compass on A. We'll move our arc down a little, and then we're going to draw an arc across this one, our original angle. So here's our arc. Okay. Label the draw an arc that intersects sides A. Label the points B and C on your intersection. Okay, so this is point B, and this is point C. Okay, with the same compass settings, put the compass point on point S and draw an arc. So I'll pick up my compass. I'll take it down here to S. We'll get our ruler out of the way for a second. And we're going to draw this same arc. Okay. All right, so now I know I have a side and an arc that matches. Okay. And then point of intersection at point R. So this is going to intersect at R. All right. Now, open your compass to the length of BC. So we have to go back up to our original, and we want to put our compass on B, and then open it up so that its endpoint is on C. Okay. So we're going to have to spin our compass a little bit to make that work. So there I am on B with a pointy end, and I'm going to slide this around and try to get it lined up. Okay. This is easier without the smartboard. All right, so I'll move this back. And I got my whole page moving, so that's not good. All right, I think that's about right. And we're going to have to slide this around a little. I'll put them both on B, I'll turn it, and then open it up. All right, there we go. Okay, so I've got my point on B and C for my compass. All right, and then with a different color, I'm going to mark a little arc right here. So now I know how long I should go on the arc from B to C. So what I do is I pick my compass up without changing it, okay, and I drop it. Did I move it? Okay, no. All right, so I pick up my compass, I put the pointy end on R, and then I draw this same arc in that we had. Okay, so now we have matching parts. It says open the compass to the length BC, keep the compass at the same setting, and put the compass point on R. Draw an arc to locate point T. All right, so here's T. T is going to be where the two arcs intersect. And then we're going to draw in ST, and we'll have angle S to be the same size. All right, so we'll put this on here, and then we'll go through the steps one more time, because it took me a little while with drawing on the smartboard here. All right, now these two angles are the same. All right, so one more time, see what we did. First thing we did was just draw a ray, same as before, down below. And then we took our compass and we just opened it up to any old place we felt like that fit on the first angle, so that the point was on A and the writing end was out on the angle. And then we drew an arc. We labeled the 2 points where it crossed the sides of the angle B and C. You don't actually have to label them. Then we went down here and drew, without moving our compass, the same arc. Okay. Once we were done with that, we took our compass one more time and we measured the distance between B and C with our compass. We put the pointy end on B, the writing end on C, and we drew another arc. And then we picked up the compass without changing it, moved it down here, put the pointy end on R, drew the same arc, and where the two arcs intersected, that's where point T went, and now our two angles are the same length. Okay? So it's a little tricky. You got to do a bunch of measurements, so you might want to check it out, see if you could do it yourself one time before we do it. Okay? All right, so this one give you a chance to practice. Our second one is to construct angle F so that the measure of angle F is equal to 2 of the measures of angle B. So very similar to the last problem. We have B here, we just want to make FB twice as big. Okay, so it's not too bad to do. All right, so let's see how we do it. I want you to pause the video, see if you can figure it out from the steps above, and then come back and watch when you are done. So welcome back. Let's see if we did about the same thing. So I take my straight edge. I'm going to do this. I'm going to draw one side of my angle here. All right, and I know that this is going to be B, or F actually, and F has to be twice as big as B. All right, so we're going to do pretty much the same steps, except we're going to repeat it twice. Okay, so I'm going to go over here, and I'm going to draw an arc starting at B that goes through the original angle. Okay, so like this. All right, then without moving my compass settings, I'm going to take it and sit it on F, and I'm going to draw the same arc. But I'm going to make it really big this time because I know that F needs to be twice as big as B. All right. Now, last time we just need to measure the angle, and what we did was we put this one here and that one there. So I'm going to turn it around so I can hopefully see it. That didn't help me any. All right. So I got to get this guy lined up. I need to get the green one on there. So let's see if I can do that. Oh, that was good luck. Okay. Now I got the pointy end on one of those and the writing end on the other part where the arc intercepts the angle. And I'm going to draw a new arc to show where it is. Okay. Now that's the size of angle B. So when I go over here and drop my pointy end on this one, then I can draw B. So I know right here's where B is, but I want my new angle to be twice the size. So all I have to do is pick it up and put the pointy end where this arc goes and draw it one more time. Okay? And then our new angle F will be twice as big. And the intersection where that point's going to be is right here. This is where I need to draw F and draw through. So let's take our ruler and go ahead and draw through it and make our F angle. All right, so we slide it down. Get on the point again. And then we'll spin it up. All right. Now I've constructed angle F, and angle F is twice the size of angle B. All right, our last thing on this page is the definition here about perpendicular lines. Perpendicular lines are two lines that intersect to form right angles, and we use this symbol usually to show that two lines are perpendicular. So how do you mark a drawing of two lines as being perpendicular? Well, let's see. So let's see if I want line L to be perpendicular to line N, or M there, then I do this. There's L, there's M. Okay, and then that little square shows they're perpendicular. So this little square here shows perpendicular. And what is a perpendicular bisector? A perpendicular bisector is a line that cuts a segment into two equal parts. Okay. All right, let's flip it over, and we have two more constructions on the backside. The first one's going to be constructing a perpendicular bisector. Okay, so to construct a perpendicular bisector, I think this is one of the easier ones. You put the compass point on point A. So I take the pointy part, and I slide it on A, and then I open up my compass so that the writing edge side of it is past the midpoint. So that just means more than halfway. Okay, and then we're going to draw a big arc. Okay. All right. With the same settings, though, we then pick up our compass. We put the pointy part on B. Okay. And we're going to draw another arc. Okay. Where the two arcs intersect, let's get this out of the way, is we're going to put points X and Y for our perpendicular bisector. So there's points X and Y. And then we just use a straight edge and we draw it in. Okay, so step 3, connect X, Y. And here is our perfect perpendicular bisector. And we're supposed to label everything to show that it is a perpendicular bisector. So we'll put a right angle mark in here. And then we'll show this thing and this thing to show that split that segment right in half and with a right angle. So it's a perpendicular bisector because it's perpendicular to AB, XY is, and it's a bisector because it splits AB into 2 equal parts. Okay. All right, our last construction. Construct an angle bisector. So this one I think also is a pretty clever one. So first step is to put the compass point on vertex A and draw an arc that intersects the sides of A. We're going to label those 2 points B and C. So here's our arc. We intersect the sides of angle A. We're going to label this B and C. Doesn't matter what size we put on it, just make the arc, okay? Now put the compass point on C. We can reset our compass or we can just leave it the same. It doesn't matter. So I'm going to put mine on C and draw a arc again. And the place where we want our arc is going to be out here somewhere, okay? And then we're going to put the same one on point B without changing our settings. Okay, so I set it on B and we'll draw another arc. And where these 2 arcs intersect, we're going to go ahead and label that D. And this will make AD be my angle bisector. So I just bring in the ruler and we set it on here. And it's got to go down a little. There we go. And right there. So AD is an angle bisector. Now, how do we make sure that we know that this is an angle bisector? So label the point where the 2 arcs intersect as D. We did that. And draw in AB, AD, and diagram to show that BAD is congruent to CAD. So here's BAD, and we want to show that they're congruent. So I can put a mark here and a mark here. Okay, and I'll use that arc to help me. All right, so I have BAD and DAC are congruent, and that means that AD is an angle bisector. All right, I will see you in class next time. We'll practice a lot of these constructions and get you used to doing them, and hopefully the steps will stick into your brain. All right, see you then.